Hi students, I'm sorry I can't be there today, but I'm here with you through this video. So we're going to start today with reviewing the system analysis. This is kind of the overview of where we are in the unit. So first and foremost, I want you to fill out these bar charts for the starting position of the jumper and then the final position of the jumper. I'm going to zoom in here so you can see what I'm talking about. So here you have the system component. So you have the person, the energy in the energy in the spring, and then your total energy. Okay, so using this legend, you're going to use these colors to show what kind of energy the person has and the spring has at each position. So pause the video now and fill these out. Okay, so what you should have gotten is that at the starting position, the jumper hasn't jumped yet, so he or she is not moving. The elastic cord isn't stretched yet, so all of the energy is gravitational energy. So you would click this, let's make a copy of it, drag it down here, and it's all gravitational energy. So the total energy, I just made another copy there, is all gravitational. Okay, there was no transfer of energy, no transformation of energy just yet because it's all in the person. If we scroll down in the final position, this is after the person has jumped, has fallen, and the bungee cord is stretched to its maximum position. So the bungee jumper is at its final height. So do we still have gravitational energy? Yes, we do, because there is still space between the jumper and the ground. Anytime that you are above the ground, you have gravitational energy. Okay, so we would take this gravitational energy, I'm going to make a copy of it, and place it there. But what we do know is that the gravitational energy has decreased because their position above the ground has decreased. So this needs to actually be much smaller. There are just a couple of units, maybe 1 or 2 units of gravitational energy. So that makes up part of our total. And then to find out the rest of it, we have to think about this. So we know that there is no kinetic energy at the very bottom position. And the reason is because the jumper has fallen, their velocity has reached to 0. If you recall, I'm going to switch slides here just to show you what I'm talking about. If you recall, the equation for kinetic energy is 1/2 mv squared, right? So kinetic energy is calculated using 1/2 times the mass of the jumper times its velocity squared. And if that velocity is 0, then the whole equation is 0. Okay? And the reason why they come to a velocity of 0 is because that jumper needs to switch directions. So the jumper is falling down, and then at the very bottom has to go back up. So that velocity needs to get to 0. This is important, and you'll see why in the activity or the assignment that you're going to do today. So there's no kinetic energy at the final position, but we do have elastic energy. And that's because the spring, which is the purple part here, the spring has completely stretched. So whatever is left is all elastic energy. That moved, sorry. So I'm going to grab this here. I'm going to copy it, bring it down, and place it here. It's not all the way up because we have to account for the gravitational energy that is in the jumper. So the total energy is made up of a little bit of gravitational and mostly elastic. If you have not taken the first quiz, which covers the energy bar charts, then you will have an opportunity to make up that quiz on Friday when you take your second quiz. Okay, so moving on. So now that we know what kind of energy we have at this position, we can actually calculate it. So looking back at that same lab that I just showed you, the kinetic energy lab, the equation for gravitational energy is the mass times the gravity times the height. So in this case, for this box, in this box I want you to write mass times gravity times height. Oh, excuse me, starting height. It's important that you put starting height, not just height, because we're talking about the gravitational energy at this position. Okay, scrolling down, we can also calculate the gravitational energy at the final position using the same mass times gravity, which never changes, right? Gravity is always going to be 9.8, or you can use the number 10. Either way works for me. Times, now we take the ending height. Okay, so same equation, just different heights now because they're over here now. The elastic energy then, we could use the equation that we found in our elastic energy lab, but an easier way to find the elastic energy is to take the total energy minus, well, let's say this. The total energy we calculate here, right? This is the total to start with. So we're going to take the starting EG, which is the same thing as the total because total is made up of the starting EG, minus the ending EG. Essentially what we're doing here is we're looking for the, quote, missing energy. But remember that this energy is not really missing because of the law of conservation of energy, right? That tells us that we can't create energy, we can't destroy energy, so we have to account for it somehow. So we have some energy here, and then the rest of it we find by subtracting it from the original total.